Hello everybody. In our previous videos we have studied about finding the areas of circles. We studied about finding the areas of a combination of plane figures. Now in this lesson we will study about finding the surface areas of a combination of solids. So welcome to the lesson. You are familiar with some of the solids like cuboid, cone, cylinder and sphere as you see over here. You have also learned how to find the surface areas and volumes in our lower grades. In our day-to-day lives, we come across a number of solids made up of combinations of two or more of the basic solids shown over here. You must have seen a truck with a container fitted on its back, something like this, carrying oil or water from one place to another. Is it in the shape of any of the four basic solids you see over here? You may guess that it is made up of a cylinder with two hemispheres at its ends. Again, let's see this. You may have seen an object like this. Can you name it? A test tube, right? You would have used one in your science laboratory. This tube is also a combination of a cylinder and a hemisphere. Similarly, while traveling, you may have seen some big and beautiful buildings or monuments made up of a combination of solids as shown over here. If for some reason you wanted to find the surface areas or volumes or capacities of such objects, how would you do it? We cannot classify these under any of the solids you have already studied. So in this video and our forthcoming videos, we will see how to find the surface areas and volumes of such objects. Let us consider the container of the truck once again. How do we find the surface area of such a solid? Whenever we come across a new problem, we first try to see if we can break it down into smaller problems we have earlier solved. We can see that this solid is made up of a cylinder with two hemispheres stuck at each other. A cylinder and two hemispheres stuck at each other. So when we combine them, we get this. It would look like what we see over here after we put the pieces together. If we consider the surface of the newly formed object, we would be able to see only the curved surfaces of the two hemispheres and the curved surface of the cylinder. So the total surface area of the new solid is the sum of the curved surface areas of each individual hemisphere plus the curved surface area of the cylinder. So we can find the total surface area of the new solid equal to the curved surface area of one hemisphere plus the curved surface area of the cylinder plus the curved surface area of the other hemisphere, where TSA means total surface area and CSA means curved surface area. So we can find the total surface area of the complete object by splitting it into two hemispheres and a cylinder and then adding them up together. So this is how we solve complicated problems. Break them into simpler ones of what we have studied earlier and then bring the solutions together. Let's try to understand it from another scenario. Let us now consider another situation. Suppose we are making a toy by putting together a hemisphere and a cone. Let us see the steps that we would be going through. First, we would take a cone and a hemisphere and bring their flat faces together. Here, of course, we would take the base radius of the cone and the radius of the hemisphere, for the toy is to have a smooth surface. So the steps would be something like this. You have a cone, you have a hemisphere, take the flat faces of the cone and the hemisphere, join them together, and then you get a nice toy. So at the end of our trial, we have got ourselves a nice round bottom toy. Now, if we want to find how much paint we would require to color the surface of this toy, what would we need to know? We would need to know the surface area of the toy, which consists of the curved surface area of the hemisphere, and the curved surface area of the cone. So, to find the total surface area of the toy will be equal to the curved surface area of the hemisphere plus the curved surface area of the cone. So, let us consider some examples in solving the problems with this idea in mind. Let's try this problem. Rashid got a playing top as his birthday present, which surprisingly had no color on it. He wanted to color it with his crayons. The top is shaped like a cone surmounted by a hemisphere, as you can see it in the figure. The entire top is 5 centimeter in height and the diameter of the top is 3.5 centimeter. Find the area he has to color. You can take pi to be equal to 22/7. So, if we have to paint the entire toy, which is called a top, in Hindi it is called lattu, then we will find the total surface area of the toy. How will you find the total surface area of the toy? We can find it by finding the curved surface area of the hemisphere plus the curved surface area of the cone, and then we add them together, we will get the total surface area of the toy. So, the total surface area of the toy is going to be curved surface area of the hemisphere plus curved surface area of the cone. So, now let's get to work on finding the curved surface area of the hemisphere. But in your lower grades, you have learned what is the formula to find the curved surface area of a hemisphere? Of a sphere is 4 pi r squared. Hemisphere is half of it, so it's going to be half 4 pi r squared, isn't it? Because this is half of it. So, half of 4 pi r squared, it will be equal to 2 pi r squared. What is the diameter? 3.5. So, what will be the radius? It will be 3.5 by 2. Let's not get into calculating how much it is. So, the radius is going to be 3.5 by 2. So, we can now plug in the values very easily. So, 2 times pi is 22/7, radius is 3.5/2 squared. Obviously, we will multiply it itself twice. And then this will be the curved surface area of the hemisphere. Now, we can move on to finding the curved surface area of the cone. In order to find the curved surface area of the cone, we need to find the slant height of the cone. In order to find the slant height of the cone, we need to know what is the height of the cone. Now look, the height of the cone will be the total height of the top minus the radius of the hemisphere. We already know what is the radius of the hemisphere. It's 3.5/2. What is the height of the top? 5. So, can I find the height of the cone? That's going to be 5 minus 3.5 by 2. So, the height of the cone is going to be equal to 5 minus 3.5 by 2, which is going to be equal to 3.25. So, now we know the height of the cone. We also know what is the radius of the hemisphere. Can I use Pythagoras theorem now to find the slant height in this triangle? Because this triangle is going to be a 90-degree triangle. So, let's see what we get. So, if we have to find the slant height of the cone, we can use Pythagoras theorem. L happens to be the hypotenuse. So, it will be square root of r squared plus h squared. So the slant height of the cone is going to be square root of r squared plus h squared. R is the radius of the hemisphere, which is 3.5 by 2, and we already found out what is the height of the cone, which is 3.25. So plug into those values and you get, let's put it here, 3.25 squared plus 3.5 over 2 the whole square. Simplify that, and that's going to be approximately equal to 3.7 centimeters. So now we know what is the slant height. We know what is the radius of the cone. We know what is pi. So can we find out the curved surface area of the cone now? So we can now find the curved surface area of the cone. What is the formula to find the curved surface area of the cone? It is pi RL. Pi RL. We know what's the radius, 3.5 over 2. We know what's L, it is 3.7. Plug it in and you get 22 over 7 times 3.5 over 2 times 3.7 centimeter squared. Let's not work it out, let's keep it over there. So now we have found out what is the curved surface area of the cone. We already found out what is the curved surface area of the hemisphere. So how will we now find the total surface area of the toy? You add these two together. So the surface area of the top will be equal to the curved surface area of the hemisphere plus the curved surface area of the cone. Now we can easily simplify this and see what we get. We can cancel 1 2 with 1 2 over here. Now 22 over 7 times 3.5 over 2, 22 over 7 times 3.5 over 2. They are common in both. So can I remove them out as common terms and see what we get? So if we simplify by removing 22 over 7 times 3.5 over 2 as the common factor, what are you left with in the brackets? You're left with 3.5 plus 3.7. Now when you simplify this, what do you get? You get 11 over 2 times 3.5 plus 3.7. Simplify that further and the answer is 39.6 centimeters square. So the area of the toy is 39.6 centimeters square. Pretty easy problem. The only thing is you need to break it into parts, solve each part separately, then add the areas of the two parts together. You will get the answer. Great going. Let's move on to the next example and see how do we go about solving that. The idea remains the same. Let's try to solve this. A wooden rocket is in the shape of a cone mounted on a cylinder, as shown in the figure. The height of the entire rocket is 26 centimeters, while the height of the conical part is 6 centimeters. The base of the conical portion has a diameter of 5 centimeter. The base has a diameter of 5 centimeter, while the base of the cylindrical portion is 3 centimeters. So if you have to just pull that out to understand it better, we can get this here. So this is the base of the cylinder, the diameter of which is 3 centimeter, and the base of the cone, the diameter of which is 5 centimeter. So let's continue reading. If the conical portion is to be painted orange and the cylindrical portion yellow, find the area of the rocket painted with each of these colors. You can take pi to be 3.14. Let's pull out the figures and zoom in on them. With regards to the cone, let r be the radius of the cone, L be the slant height of the cone, and h be the height of the cone. With regards to the cylinder, let's r prime be the radius of the cylinder, h prime or h dash be the height of the cylinder. Now looking at the circular parts of the cone, The bigger circle is for the cone and the smaller circle is for the radius, for the cylinder. And as per the question, the diameter of the cylinder is 3 centimeters, the diameter of the cone is 5 centimeters, the basis. Now, do we know the radius of the cone? Yes, which is 2.5, half of the diameter of the base of the cone. Do we know what is the height of the cone? It is 6 centimeters as given in the question. Can we find the slant height of the cone using Pythagoras theorem? Of course we can. So, radius square root of r squared plus h squared. Plug in the values and you get 6.5 centimeters. So, we know what is the slant height of the cone. Let's have a look at the figure once again. We want the conical part to be painted orange. So, in order for the conical part to be painted orange, if you observe, the base of the cone is resting on the base of the cylinder. So, only a part of the cone is outside the base. So, only a part of the base of the cone has to be painted in orange and the curved surface area of the cone has to be painted in orange. So, the area to be painted in orange will be equal to the curved surface area of the cone plus the base area of the cone minus the base area of the cylinder. So, now we can calculate what it is. So, the curved surface area of the cone is pi r L. The base area of the cone, which is the form of a circle, is pi r squared. And the base area of the cylinder is also a circle, pi r prime squared, because we have taken the radius of the cylinder to be r prime. So, the formulas will be like this. So, pi is common in all, so we can remove pi out and plug in the values respectively. So, what will we get? If we take the pi out, the radius of the base of the cone is 2.5. We found out the slant height of the cone to be 6.5 plus the radius of the cone 2.5 squared minus the radius of the base of the cylinder, which is 1.5 squared, because the diameter of the base of the cylinder is 3 centimeters. So, plug in these values and when you simplify, what do you get? You get pi times 20.25 and that's going to be 3.14 times 20.25 and simplify that and you get 63.585 centimeters squared. So, this is the area that has to be painted in orange. Now, we will go to the area that has to be painted yellow, that is the curved surface area of the cylinder plus the area of one base of the cylinder. We need to find the curved surface area of the cylinder plus one base of the cylinder. Let's see how we go about. So, the area to be painted yellow is going to be the curved surface area of the cylinder plus the area of one base of the cylinder. Now, what is the formula to find the curved surface area of the cylinder? It is 2 pi r h, and for the cylinder in this problem we are representing r as r prime and h, the height of the cylinder, as h prime. So, curved surface area of the cylinder is 2 pi r h and the area of one base of the cylinder is pi r squared and r prime squared. So, now pi r is common in both the terms. So, if we remove pi r out, we are left with 2h plus r, of course with primes. We know the values of h, we know the values of the radius of the cylinder and pi. So, plug them in and you get 3.14 times 1.5 times 2 times the height is 20 plus 1.5. Simplify this and you get 4.71 times 41.5. Simplify this further and the area that has to be painted yellow is going to be 195.465 centimeters squared. So great going. Divide the problem into parts and then work them out diligently, carefully, but you need to know the formulas, what you need to plug it in. Let's try another one. Let's try this. Mayank made a bird bath for his garden in the shape of a cylinder with a hemispherical depression at one end, as shown in the figure. The height of the cylinder is 1.45 meters and its radius is 30 centimeters. Find the total surface area of the bird bath. Take pi to be 22/7. So let h be the height of the cylinder and r the common radius of the cylinder and the hemisphere. So then what do we get? If we have to find the total surface area of the bird bath, that is going to be equal to the surface area of the cylinder plus the curved surface area of the hemisphere. We already know what is the formula to find the curved surface area of the cylinder, which is 2 pi r h. And what is the curved surface area of a hemisphere? 2 pi r squared. So we can just plug in the formulas. We know the radius, which is 30 centimeters, and we also know what is the height. In this case, before we even go to plug in, 2 pi is common in both, 2 pi r is common in both the terms. So we can remove 2 pi r common and we are left with 2 pi r into h plus r. Plug in the values for h and r. You get this. Simplify. So we know the radius, we know the value of h. Plug it in, simplify, and you get the total surface area of the bird bath to be 33,000 centimeters squared. If you change it into meters, it's going to be 3.3 meters squared. Great. I really appreciate the effort that you have put in into understanding the concepts of this lesson. Work out more number of problems, right? And increase your skills in identifying problem solving. Remember, your results will be in proportion to the efforts that you put in, and your results can increase by persistently working on more number of problems. So keep working, do not give up. Thank you very much for watching this video, and do share and subscribe to this channel, Wisdom Outlined, and looking forward for you to view my further upcoming videos on this lesson. Thank you.